Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.119. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.119. Find the value of current I0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this branch labeled as I0. So without wasting time, let's proceed towards the solution. If we focus on this network, this is a parallel network. So first of all, we have to assume a voltage across this network. I am assuming voltage V0 is appearing across this network with this specified polarity. Now the second task is to label this branch current. I am assuming current Ix is flowing through this branch in downward direction. Direction of this current in downward is made in order to make this terminal positive, because we know that current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign. Now first of all, we have to find the equation of current I0. For that purpose, we will use Ohm's law. Voltage across this 6 ohm resistance is V0 and the value of resistance is 6 ohm, so we can calculate the value of current I0, that will be equal to V0 divided by 6 ohm. Similarly, current Ix will be equal to V0, that is the voltage across these two resistances, divided by the sum of these resistances, because these are connected in series connection. Now in order to calculate the value of Vx, we will multiply this current Ix with the value of this resistance, that is 4 ohm. So voltage Vx will be equal to Ix multiplied by 4 ohm, while the value of Ix is V0 divided by 12 ohm. Now this 12 will cancel out with 4. So the equation for Vx will become V0 divided by 3 ohm. Now we will apply Kirchoff's current law on this node to calculate the value of voltage V0. If we succeed to calculate the value of voltage V0, we will put that value inside this equation to calculate the value of current I0 that is required in this scenario. So first of all, write Kirchoff's current law equation for this particular node. On this node, only one current is entering, while rest of all other currents are leaving from this node. Entering current is taken with positive sign, while leaving currents are taken with negative sign. This current is the current through this dependent source, that is 3 times of Vx. This equation have multiple variables, so in order to solve this equation, we have to replace all these currents with their respective equations. Current I0 is equal to V0 divided by 6 ohm, while current Ix is equal to V0 divided by 12 ohm and Vx is equal to V0 divided by 3 ohm. These 3 will cancel out with each other. The equation will become 5 minus V0 divided by 6 minus V0 divided by 12 minus V0 equal to 0. Now in order to omit all denominator values, we will multiply this equation with 12 on both sides. Product of 12 and 5 will become 60, while the product of 12 and V0 divided by 6 will become 2V0. These two 12s will cancel out with each other and only V0 will left. Product of 12 and V0 will become 12V0. Now add all these variables together, their sum will be equal to 15V0. Place this minus 15V0 on the other hand side of equal. So the equation will become 60 equal to 15V0. Divide on both sides with 15 to calculate the value of V0, that will become 4 volt. Now we have the value of V0. So we can place this value inside this equation to calculate the value of current I0, that will be equal to 4 volt divided by 6 ohm. So the value of current I0 will be 0.67 ampere. So this was exercise problem number 2.119. Thank you. See you again in next video.